Welcome. Thank you all for coming. Today's speaker, the prodigal son returns, graduated from SUNY Oneonta in 2010 and is currently a professor at SUNY Broome. Rick also taught at the University of Connecticut while he attended as a graduate student. He is active with the students of Broome, serving as the student advisor for the Math Club and as the coordinator for the systematic math competition. I did that one.
It's a two-year college one, so.
Rick resides in Roscoe, New York, fishing capital of the world.
Yeah, apparently.
With his wife and 3 children. And today he'll be talking about teaching math through games in higher education.
Well, thank you. All right, so hi, glad to be back, on campus. The building's amazing. So, because it wasn't when I was here. I guess that's all I can say about that. So some of you look younger, you don't really know what I'm talking about most likely, but there used to be half floors where the offices were like in between and you could never find anything. So you guys should feel really good about it. So today I want to talk a little bit about using games to teach math. Specifically, this is targeted around discrete math. So being at a community college myself, the students I get into discrete math course are not really math majors. Yeah, we get more the comp sci kind of crowd because we're a tech school. Yeah. So as such, I'm not going to get a student who's excited about set theory because it's set theory. Yeah. Maybe those don't exist anyway. I'm not sure. But the same thing. Probability. They're not necessarily going to be excited about probability because it's probability. Graph theory. A bunch of dots on a piece of paper. Yeah. So it's hard to get them really bought into especially the proofs part. I haven't yet figured out how to bring the games into the proofs part of it. If anybody has a suggestion, let me know afterwards. Still working on this project of converting the course a little bit, right? And about that. So, right. So here, first slide, a little about me. He kind of already said a lot of this stuff. I'm in the 8th year. Really for myself, really games and puzzles have been my life. Right. I was playing Rummy by the time I was 7, and Monopoly, Risk. My brothers growing up, we used to take Monopoly and Risk playing at the same time, where you could use the money from Monopoly to buy armies. And on a turn, you do both. Yeah, like stuff like that. So really games are kind of a big deal. My wife and I, Katie Sustak, when she was here, right? We do escape rooms a lot. It's just what we love. Yeah. So if you were to go into my living room, you see a whole bookshelf of kids' games. My kids are age 4 and 6, and they have about 30 different games ranging from Kids Ticket to Ride, Kids Monopoly, to Uno, to games where you stick your face on a little hand and push a button a couple times, and maybe you get smacked with a pie. But games are big for us, yeah. So I faced this problem in my class of trying to figure out how to get kids into these topics a little bit. Yes. A little bit abstract for a lot of them, and a lot of them you can give them an idea that's a physical thing, but people don't connect to an idea all the time, right? Like say, okay, the practicality of a traveling salesman problem. Yeah, for those who know the graph theory. It's practical. The guy needs to go to the certain spots. He wants to do it while walking the least because he's lazy. We're good, right? But they don't connect to that. Yeah, it's an idea, it makes sense to them, but they don't connect to it. So connection, I think, happens a lot more when you give them something to do while thinking about the math. Okay, so that's where the games came into play. So for me, it was a way to give them actions to take to actually take the math they're studying and apply it to something, right, that they're physically doing. So the goal was to give them this experience to connect. Now, there are challenges with putting this into the course, right? Because, a lot of you guys know, not a lot of extra room in a semester, right? For those of you who are professors and those of you who are future teachers, you'll understand, right? You don't always have extra room. So the biggest challenge to doing this was the time aspect, yeah? How do you fit playing games in the classroom into your semester? The second challenge with this was trying the resources aspect, yes? So if you're gonna do this, you need enough copies of the games for everybody to play. That costs money, right? So I'm still working on getting all the games, enough copies of all the games to do all of these things in the classroom, but that's in process. So the time thing, especially after mostly just picking like one game here and there and doing more experimenting with playing a game in class, kind of what I arrived at is this should kind of go like a science lab. Yeah, a lot of science labs, what do? You have them do kind of a pre-reading at home, right? Where they read a bunch of background. So in that, usually I want them to already have explored the way the game is played. Yeah, so you want to try to explain the game so they come in kind of knowing how to play. Also, in a lot of cases, I want them to also explore the math that they're going to be somehow relating to the game, right? So sometimes that's something that has to be taught ahead of time. Sometimes it's something that can be part of an at-home, almost like flipped room type approach. Okay, so that varies depending on what's going on. So that's key, is getting a lot of that background out of the way ahead of time so that the game can take the time for class, right? So during class, while they're playing, they should already be thinking about certain things, and they should be able to try to connect them. But I have them record certain moments in the games that they can revisit later, right? And actually do some calculation kind of stuff that applies to that moment. Okay, so then they can look back, see if they made good decisions or bad decisions, things like that. So that happens in this post-lab part. All right, so first topic. So there's a lot more games that I've worked on being able to use for this than just the ones I'm going to present here right now. Some of them work better, some of them are still kind of, I'm still kind of working on the assignment, right, to make enough applicable to work in the class. So for set theory, I've got two that I think have worked fairly well. One is my kids' game. So hopefully they don't ask to play this when they go home from school today because it's off their shelf. Anybody remember this game from when they were a kid? Guess who? If not, you missed out. Yeah. So this is the first one. And then the second one is this other game. You can't see anything from the cover. This one I didn't know about. My department chair did. So when I started working on the project, he gave me the idea. His name is Timmy Bremer. So guess who? Let me go to the picture first, right? So you have a bunch of characters, and they've updated the pictures since when most of us were kids. It won't look exactly like you remember. But you got a bunch of pictures of people, and the game is where each player is technically one of the people, but it's hidden, right? So what players do is they take turns asking yes or no questions. It has to be a yes or no. We can't ask like what color is their hair. Yeah, just a yes or no. Okay. The other player then answers, yes, my hair is black. Yeah, or no, it's not black. Right, that kind of question. And from this, the players whittle it down. The first player to figure out who the other player is, who the other player is wins. Right. Pretty simple game. This works pretty well. There's a handful of set theory things that they can really investigate that are basic stuff pretty quickly from this. The first being sets and their complements, right? They ask a question that breaks the group of individuals into the set that is the yes and the complement, which is the no, right? So sets and their complement comes into this very naturally. They can look at intersections as they ask consecutive questions, right? They then start intersecting the sets, yes? And then anytime you're dealing with sets, complements, and intersections, what's the natural thing to have them do with it? Venn diagrams, right? So pretty straightforward here. A typical assignment would have them draw Venn diagrams for kind of after each question they ask that represent the game up to that point, right? And they would do a little pre-exploration with the pictures, okay? All right, some advantages to this one, and like I said, have those challenges in mind. One, it's easy to learn and explain. It's a very simple game to pick up. It's a kid's game. Right? So it's quick, you can get them going very quickly on it. It doesn't take too long, so you can have them play a couple rounds and it'll only take the first half-hour class if you want, right? It doesn't have to take all class to play a game. And also the game itself at this point, you know, is not super expensive. We're not talking about a game that's $60 a copy, right? You can get these cheap versions for $20 a copy, or there's even stuff online where you can print out things resembling those picture panels that I showed you a second ago. So you can possibly even just do something like that, right? So this is a pretty easy game to fit in. The next one, the game On Sets here. So this one requires a lot more pre-knowledge. So the people will need to know already. They can't investigate while playing it, how unions work, how intersections work, how complements work, set differences. A lot of those operations need to be known ahead of time, okay? They also need to know cardinality, but that's simple because we're not talking about infinite sets. In this game, they're all going to be finite. So the way the game works is a pool of dice is rolled at the very start, okay? And over the course of the game, players are taking those dice and moving them to other purposes. So this is a picture of the stuff in the game. So here we have cards, which represent the cards are kind of the elements that can be in the sets. Okay, so, and the sets are grouped by colors. So in the bottom right here, we have a card that has red and green on it. So that's part of the red set and part of the green set, not part of the others. Right? Pretty simple on that one. If you can see the dice well enough from where you guys are, you'll notice some of them have colored dots, some of them have numbers, and some of them have set operation symbols. The rule book tells you which sets some of the symbols are meant to represent. Some of them are a little outdated from the way most of our textbooks do. So like the complement is the apostrophe, right, rather than a bar over it or something. But you know, you can look that up in the rules. It's not too hard, yeah, for that kind of thing. So what happens when you play this game, right? At the beginning of the game, it's going to be established from the number dice what cardinality people are trying to create, okay? So the rest of the game is played where players take turns moving single dice, one dice per turn, to either a spot where players are not allowed to use it, players are required to use the dice, or have the choice to use the dice, okay? And you take turns with that. At the end of the game ends when somebody is able to take the dice that are required, add in some of the optional if they want, and create a set expression which has the desired cardinality. Oh, wrong way. All right, so for example, right here we have a starting game for 2 players. We've got our 6 cards here. We have a union, an intersection, and a set minus rolled for operations that are available. We've got 2 red dice, a blue dice, and a yellow dice for the colored ones. And then the cardinality here that we're targeting is 4, okay? So people are going to be trying to create a set where the cardinality of what you created is 4. And you have to build that out of these dice. So just to keep a short example, not a lot of turns, right? Maybe one that gets there kind of quickly. But let's say the first player decides one of the red dice is required. Right? That means any expression the person puts down has to use that dice at the end. Pretty simple. So far, that would only allow you to create a set with cardinality 5. Right? There's 5 cards with red on it. So nobody can yet get to the 4. Let's say the next player then puts blue in the permitted, right, or optional category. Well, we still have to use the red dice, so we can still create 5, but there's no set operation yet, so that's still all we can do. Right? You can't do anything with red and blue, right? There's no combination dice. But the next player at this moment should be able to look at this and say, well, if I take the red set and I remove the overlap with blue, set minus, yeah, I'm left with only 4 of the red ones. So the next player would at this moment be able to say, okay, well, I'm going to choose the minus dice as my next one, and now I can create the expression which has the cardinality of 4. So it's a little more complicated. One of the downsides to this one is it really does take a little more time to learn and feel comfortable with. I can see it on your faces. Right, so when my department chair brought it in, he walked in like literally 1 minute before my class ended one day. I was like, we got to try this game. So we didn't even leave the classroom. We were like, we got 10 minutes, all right. And then when I realized I needed to play it 3 more times to understand it. So it's a little tougher to get down, but the games only take 5 or 10 minutes each. They're pretty quick. as long as people don't just sit there and stare at it, right? So you can play you can let people play 3-4 games in that first half of class again to get the hang of it, but they have to understand the operations and how they work, right? But what it does is it really gets them a chance to explore how well they understand what these operations are really doing, okay? So this one actually, people do take a lot out of this one from what I've seen, who have tried it out with us so far. But like I said, it takes time to learn. They need to know set operations beforehand. Good news, games are short. And once again, at this point, it's not a super expensive game. If you go online to like auction sites, you can even get like fancy wooden like super old antique version copies of the game for 20 bucks or something. So it's another one that's not super crazy expensive, okay? Which is a plus in this case, especially with budgeting the way they go nowadays, right? All right, next topic that I've got a couple games here to mention is probability. So one of my favorite for probability is backgammon, right? And there's two major things here at play. I think the two biggest settings that come up in class for probability is very often are card-based or dice-based. I have trouble getting myself out of that groove sometimes. I don't know about you guys, but they're really common. So backgammon is a good game for dice. How many of you know backgammon? I mean, it's a classic. If you don't know backgammon, you should. It's a great game. I mean, the games, when people know how to play, do not take very long. They're pretty quick, and it's a very good game. But you have a board that looks something like this, and the deal is you are moving your pieces. I might have flipped setup, but sorry. It's math topologically. Anyway. So from this perspective, you would be the black player, the player with the black pieces here, because that's the starting spot where you have 2 in the corner. Okay, and you're moving all your pieces from here clockwise around this way. Okay, the red player will be moving from here counterclockwise around the other way. Okay, on this game. So not to get too bogged down in spending too much time on the details of playing, but some of the things that happen when you do a turn, you roll 2 dice and you move both dice separately. Okay? You can move the same piece both times if you want, or you can move 2 different pieces. Doesn't matter. You cannot move a piece to a place that the other player has 2 or more pieces on already. Yeah. So for example, just in a starting spot like this, as the black player, if I rolled a 4, I would not be able to move this piece here because they have it blocked, right, with more than 2 of them. 2 or more, actually. Okay, so there's some advantages to creating spots that have 2 or more pieces. And with that comes trying to set yourself up to have a better chance to do so. Enter probability, right? So that's one of the things I get into. The other thing is if you move a piece on top of a spot that your opponent only has 1 piece, their pieces are removed from the game and put on this middle bar. And they do not get to move any other pieces till it comes back in. So there's also a strategy to knocking your opponent's pieces out. Okay? Now there's a lot more nuance to this, but I have to keep it to the top, right? So anyway, so that's the basic idea. So some of these things basically allow me to create scenarios that probability enters into, and people can try to decide if the probability of a reward for their move is worth the probability of a risk happening. Right, so this becomes a risk reward kind of assignment through probability. Right, so from that starting, that's still the starting one, right? From that starting one, so for example, let's say the first player I totally said things were moving in the wrong direction.
Yeah.
We adjusted.
Well, this is good. I always look for these moments in my classroom because I want my students to know that I'm just like them, except older and have already done what they did, right? So, yeah, so actually as the red player, bringing pieces around this way, right? Okay. So say we're the red player and you roll a 3-1 as your first roll. One very common thing to do with that would be move one of these pieces 1 square here and one of these pieces 3 squares here, right? Leaves 2 pieces here, so they're still a block and safe, and this would still have 4, so they're blocked and safe, right? and everything along those lines. So here's the result of that move, right? So, first thing is them identifying these kinds of moves, yeah, seeing these when they're playing. Now, one thing I like to do in the assignment for this is put the thing where at the starting spot, I ask them to figure out the probability that any dice roll allows them to create a new double, right? Any dice roll. So 3-1's not the only one, agreed? 4-2, 5-3, they notice the pattern eventually, yeah. Even some duplicates of like 1-1 or things like that. So they can look at the probability that starting here, yeah, they are next turn able to do a duplicate. Then I have them look at a situation more like this. Say their first turn was a 2-3. Okay. Well, a 2-3, a lot of players would move the same piece 3 and 2 because they want to be safe. It's a natural, you just started learning this game kind of approach. Okay. Another option is to do something more like this. This becomes interesting because now you can look at the probability that next turn you get to set up a double, right? Because now you have more options, right? Not only does 3-1 let you go here, but like 1 and 5, yeah, 1 and 6. More things create good stuff for you next turn. Fair? At the same time, though, you're opening yourself up to the other player in between. While you wait for your next turn, they could hit the pieces you just left singled, right, and put you out on the bar. So this lets people look at, okay, how much did I increase the probability of having a productive next turn? Well, what probability of risk did I intake to get that? Yes? We get some really interesting takes on that from people because people are comfortable with risk differently. So they'll get the same numbers and then their impression of if it's worth it is always interesting, yeah? So things like this, I like them. And what I do for this is I'll put specific circumstances like these two pictures in the assignment, yeah? Or I'll ask them to take a picture of the board at a key moment where they had two choices and let them go analyze it later, right? As part of the project, in the after the lab, right? Kind of part of it. Again, you can have a situation like this, right? What's the probability that one of your pieces gets hit in the circumstance? Any arrangement works, as long as you have some singles, right? The other thing you can look at is then how to get a piece back in, right? So this is the picture I have with a piece that's actually out on the bar. So as the red player on the next turn, when we roll, we have to bring that piece back into play before we can move anything else, right? Now, how you do that is you bring it into the part that's the furthest from your kind of spot, yeah, without getting too far into the rest of the game directions. So, you can look here. Red double's down here now. This got rotated different than the other pictures. I'm pretty sure now this is supposed to be where the red is finishing. I'm sorry about that. Oversight on my part? Were you willing to accept red's supposed to go here for this picture? Okay. Guess that'll be after the talk, right? So we're starting up there. So red's going from here, there. I got it. Starting from down here, around this way. So if we're the red player trying to bring it in, we have to bring it in here, the furthest from our kind of ending spot. And to do that, like a single dice of a 1 would allow us to put it here, a 2 here, 3 here, or here, 5 here, 6 here. Okay? I'm not quite right. But you're moving in from the absolute furthest, right? And you count from there. Essentially, this is spot 0. Okay? Now, with this, you also have that thing of, okay, certain spots we can't even put pieces on, right? In this particular picture, a 3, a 5, and a 6 would not help you. So certain dice rolls, you'd be stranded, right? A 3-5, you wouldn't be able to bring the piece in at all, and your turn does nothing. Okay? So here I like to give them a scenario like this and ask them what the probability is that they either bring their piece in or are stranded, right? And they get a roll that doesn't allow them to do anything. Okay? So anyway, these are just some of the scenarios that come up in the game where There's some interesting counting type probability situations, right? And they can use that to discuss whether a risk is worth taking at various points in the game, right? All right, so again, backgammon, you can get sets pretty cheaply. Heck, you can probably make one out of paper, right? And little, if you really don't have the budget. So cost is not a big problem. Once they get the game, games aren't outrageously long, but they're not as short as the other ones that I was mentioning. So they might take them 20 minutes or something. Does that seem reasonable? Okay. It is still a pretty easy game to get. Once you do 2 or 3 turns, you get the game as far as how it works, even if it feels vague right now. And like I said there as the comment, I like to give them for this one, honestly, I give them a lot of targeted probability questions, you know, like what's the probability at least one of the dice is a 6, right? That's useful for trying to figure out if somebody's going to hit you. Yes, so certain probability questions I'll have them do on the pre-worksheet. It does require them to really use the addition rules quite a bit, the addition laws for probability, because getting hit is like one of the dice is a 6 or the dice add to 6, right? Things like that. So the addition rules laws come in as well. This one people are less likely to know. So this little game here is called The Mind, very simple, not super expensive. I think it was about 20 bucks. One of the best games I ever bought though. So this game is very simple. It's just you have a deck of cards numbered 1 through 100. Yeah. And sorry, I know I put the slide with words on it, but I feel like it's easier for you to follow if I just put the picture up. So I'm just going to do that. So you got a deck of cards with 100, and you can play 2 to 4 players, and everybody gets cards. Right. The goal of the game is to, collectively as a team, put your cards down so they end up in increasing order. Right. So the smallest card gets played first, and then, you know, in order from there. Catch is you're not allowed to show people your cards, and you're not allowed to communicate in any way. Literally, no noises, no signals, no. You're you know, that whole thing. So this game is great. I played it with a guy I do some work at church with on a certain ministry, and he's 40-something-year-old, big, bearded guy, whatever. And you play with him, and you get to those points where like nobody's sure if they should play next. Right? Put yourself in the spot. You got a card. You don't know if you're supposed to play or the other one is. And the more you stare at each other, the more he giggles, and it's just it's fantastic. So it's a good game, but you know, basically this entire game is people trying to judge the probability that their card is supposed to be next. Yeah. So it's a really easy game to push into probability and a fun game to play in class that's very simple. Okay. So you can have here a picture of maybe a starting point for round 3. You play this game in rounds where each round you start with the number of cards of the round number. Yeah. So maybe this is the starting point, right? Everybody has 3 cards. Your lowest one's 25. Am I supposed to go? Yes, you don't know. I mean, I would not be quick to play in this spot, right? But what's the actual probability that your card's first? Right? A lot of times it's actually higher than people would expect for these things.
3/4?
I didn't compute it, actually.
No, I could be, I'm just making a random, 3/4, it's 3/4 of the numbers from 1 to 100 are above 25.
It's absolutely possible. That is a nice quick way to do it. You know, I think if you went formally, you're talking about, all right, what's the odds that I pick? We know what 3 of the cards are. So there's 97 cards left in the deck, right? And you're looking at what's the odds that 9 cards are chosen from the 97 that are really part of the 26 to 100.
So every round starts with all 100.
They're not all dealt out, no. They're not dealt out. So only the 12 are in play. That are pictured here. We don't know what cards are left in the deck.
Right, but just because you said this is the 3rd round.
You reshuffle every time. Yeah. So you start with your 100 card sample space, and you know, but it's combinations and permutations, I think, mostly. So it doesn't get outrageous. But I'd be really curious. Now I want to run this to see how well you estimate. But you can do a couple things. There's one, you got this other spot like in the middle of a game, right? Where now more cards have been played, so you have more information, but some people have cards left. I still got this 66, is it next, right? Take any moment in the game and just ask what's the probability you're supposed to be next, yeah? Or what's the probability you're supposed to be second, or anything, right? Which makes it easy to make probability questions out of, and it's fun to play. So this is a really good one. The other thing that happens when you're playing this game, like I said, there's no communication. So if somebody does put down a card and you had a card that was lower, you have to stop the game. And everybody gets rid of the cards that were skipped, right? And then you start playing again. Now there's also, like, this game's set up to be like video games, so you have lives and you're trying to get as many rounds as you can. So it's a pretty fascinating game, but you can take those moments and say, okay, let's stop at the moment where somebody misplayed and let's compare the probability that that person should have gone to the probability of the one that really should have gone, and say, okay, were they different enough that we shouldn't have screwed this up, right? Or were they so close that it makes sense we made them messed up? So I don't want to oversell it, but it's very easy to write problems for, and it's a lot of fun in class. Okay.
Especially if you drink.
If it's not in class, yes, then. Right. So, and I've seen people that this one I haven't used with a full class just yet, but I've had former students come in and just try it out with me. Some of these games are newer that I'm trying to add in during COVID, but I haven't taught it in classes yet since that happened. So I can only experiment with small groups of students who are willing to take extra time to play a game, right? But I've seen people thinking maybe it's a binomial probability. What's the probability that it's higher than the other 6 are higher than my card, and keep it the same each time? I've seen people with the bottom there more of a choose 6 out of one group versus a sample space of out of the whole thing, right? So there's different things. It's interesting to see how close they come to the same, right? And talk about that too with people. Why are they close versus if we do this for a smaller deck, they're not close, right? And stuff like that. So this is another game. It's not too expensive. It's pretty easy. It's very easy to learn. I mean, although nobody knows what to do when you say start, because they're like, wait, do it. But it's quick, and grown adults can't help themselves from giggling. That's the other one. All right. Last one is graph theory. Now this is not, I can't call this my baby, even though I haven't taken anybody else's stuff with what I do with it, but this is heavily studied as used for the game for graph theory. I just do what I do with it. I don't know, who has done it before me. But Ticket to Ride is a very good game. One of the downsides to this one is that it usually does take the full hour-long class to play for students, especially if they don't know the game. But in this game, you're trying to build, there's a picture of the board, right? It's naturally a graph. Yes, the cities are vertices, the edges are the little train routes in between. And in this game, you are trying to build a network of train tracks that scores the most points. Points are scored by building any track, longer tracks. So by a track, I mean just the thing between two cities. So like right here is a track with 4 pieces. Yeah, versus down here we have a track that's 6 pieces long, right? So those are 2 different edges, one length 4 or weight 4, right? If you want to do weighted graphs with this, right? Weight 6, etc. Oh, I thought you were right. And at the same time, lost what I was going to say. Anyway, so I'll just start back up. So we got the cities are the different things, and the edges are connections between cities, tracks that could be built. You'll see some of them even have double tracks, so you have double edges between some cities in the graph, right, of the same weight. So points are scored either when you build an edge. I'll use the graph theory if that's okay with you guys. When you produce an edge, you get points based on how much it is. So you get more points for longer edges and less points for shorter edges. Yeah, in a scale that's on the board there. And then the other thing for this, for points anyway, is these ticket cards. So you get these ticket cards, which give you two specific cities that you need to try to connect, right, by a line of trains. Enter paths, yes? Paths in graph theory. Fit this perfectly. You're really looking for a path between two given vertices. So here we have one that's from Portland to Nashville, Calgary to Phoenix, Winnipeg to Little Rock. They have different point values based on how far apart they are, right? And things along those lines. So to do this, you have to get these train cards and turn them in. So train cards look like this. They're different colors, and you have rainbow ones, which are wild cards. Can be used as any color. And if we want to build an actual thing here, right? Like let's say we wanted to build the track right here from Denver to Oklahoma City, I would have to turn in 4 red cards. Yeah, because it's red. There's 4 spots. If we want to build a gray one, right? Like Denver to Santa Fe is 2 gray spots. It means you can use any color, but they have to be the same, right? So you could do 2 greens or 2 yellows or 2 blues, etc. So that's the basics of the game. On a turn, you get the choice of either building a track, drawing 2 new train cards, or you can get new ticket cards, which I try to keep them from having that option in class until they finish their starting ones, because I just need them to explore the graph. Yeah. So you have to kind of tweak what rules you're using for this one. So, you know, with this one, mostly I have them look at the questions of things through the weighted graphs here, right? You can weight them a bunch of different ways. You can weight the edges by the length, how many train cards that cost to build it, right? You can actually do it by the number of turns it takes to build it, where each train card is a half a turn plus 1 turn for actually building the track, right? So a one that takes 4 cards would actually be 2 turns to get the cards plus 1 turn to build it, right? So a weight of 3. You can also weight them by the points you get for building it, right? Or some kind of ratio of points to cost. There's all kinds of ways to do this, yeah? And to build a strategy on, you can either tell your students which one you want them to do it based on, maybe the first example, and then maybe you let them explore right in the post work from there. But generally, you know, weighted graph approach, pretty good. So I grade this one out just to see it. So going back to those cards, one of them was Calgary to Phoenix. So there's a bunch of different paths. So for example, right, this would be one path you could take, right, to connect the two. Yeah, going along the West Coast there. If you add up, just going the simplest one, if you just add up the total number of cards you spent, right, as the weight, this path would be length 16, right? Different path they could choose, right? There's another path that would still accomplish the ticket card, right? If you add that one up just on the simplest weighting, right, like I said, that's length 13, yeah? Now, this is all still a little abstract, but they're in a game where they're trying to accomplish something, and they can connect the weighting of the paths to using up their resources, right? So there's connections they can make as to what these weights mean to them in the context of the game, right? And give them a connection to that information. So one of the things I do here is I do have the students take their starting cards, write them down, and later after the game, or even before the game, sometimes I'd put this in the before the game. I've played around with this one quite a bit, but I'll have them go and look at a ticket card and explore various paths they could pick and which ones are less weight, more weight, right? That kind of thing. Nope, I'm going the wrong way again. The other thing that happens here, you have in this game where you really usually have, I don't even know what time it is. Okay, you really usually have more than 1 ticket at a time. You start by getting 3 tickets, and you keep at least 2 typically, is the real rules. I just have them start with 2 and take the choice out. So with that in mind, like they're not just trying to connect 2 cities, they're trying to connect these 2 cities and these 2 cities, right? And there's pros and cons to doing them in different manners. So this allows them a chance to look at 2 different things, the idea of their graph that they're creating being either connected or disconnected, right? If they do it so that the paths intersect each other, they get a connected graph that they're producing, versus if they have a path here and a path here separate, right? It's not. So right here's a picture of if you just did the tickets individually where they don't have anything to do with each other. Yeah. In this case, the total length of those paths together would be 27. Whereas here's one where you made a connected graph, right? And this still accomplishes both tickets because you have this path here as part of your graph, and you also have that part here, path, sorry, that's getting a little dry. So they can look at the connected versus disconnected. I've seen spots where the disconnected is shorter because the two pairs are farther away, right? So sometimes there's a benefit to keeping them disconnected, and sometimes it's better to have them connected. But either way, they get to look at the connected versus disconnected, and then with this is a spanning tree, yes? So a spanning tree being a connected subgraph that contains a specified set of vertices, right? So then they can look at the idea of spanning trees, and if you're doing weighted, you can have them find minimal spanning trees. Yeah, that can be done before the game kind of thing. If you give them their tickets in advance or something, like let them know what tickets they're gonna have, they can plan out what they would like to build in the game, right? By what the minimal spanning tree would be. You know, so there's a lot of other things you can do with this game as well. That kind of gets the end of what my discrete course has in it. So there's plenty more, but that's where I kind of have to stop. Okay. So that's kind of, I was sort of looking at this maybe 45-ish minutes, and we're right around there. So I think I stopped at mostly the right spot. Like I said, there is a whole bunch of other games that I also have things that I can use them in class for laid out, some of which I've used, some of which I haven't. These ones were the ones I thought that kind of bring the most to it, as to the students can get the most exploration out of it. So, but this is an ongoing project for us, you know, me specifically at SUNY Broome. And we are trying to take the discrete course and craft a new version of it. Topics the same, that includes kind of playing games through all the topics. So these are some of them. Any questions or anything?
Have you done Lyra's dice for probability yet?
I haven't. I don't know why I hadn't thought of that one. Have you ever played that with the numbers on a dollar bill?
Yeah, I don't believe so.
Okay. We called it Liar's Poker for that one. No, that's a good game. So it should have a lot of good applications to probability.
With the backgammon, have you added into the probability how they played at the beginning and how often they would win or how quickly they could get through a game versus once they had incorporated the probability, how much better they played at the end?
That sounds like a really fun statistics project, but I'm not sure I get to devote enough class time to collect the data for that in a discrete class, because they're probably only playing backgammon maybe 1 or 2 full games, I would say. If you're willing to devote a whole class, maybe 3. But I don't know that you get enough data to get much out of that. It's a really neat idea though. Anybody else?
So when you do the ticket to ride, do you have them factor in at any point that the other players are blocking their routes along the way?
Yeah, so I like to put in on all of these some random, do you have any interesting observations about things that came up that were unexpected in the game? So I do like to have them realize those things through playing. Unfortunately, since it's not just a graph theory course, I can't have them come back and play the game again periodically through the semester to keep applying observations. But I've gone to a talk, somebody, I don't remember who it was now, which I should. I've gone to talk once for a guy who did graph theory as a full semester course, and they played this game every 2 weeks, applying new ideas from the course too. So that would be a perfect thing to bring back in after they've recognized the issue. So would you think to bring that in as probability related or?
Yeah, that, and also do you have them discuss like certain legs? If you know you got to go to Las Vegas, then there's only 2 routes into Vegas.
Yeah.
So you know you got to grab that early.
Yeah, so that I hope comes out of the observation stuff that they get to realize sometimes it's important in the strategy of the game, right? To recognize the parts of the route you really need early that you're trying to build.
Because I mean, you work probability into that by saying, the longer you wait, the less likely it is you're gonna be able to grab those.
Yeah, and I don't know if it'd be worth it, but you could, if you give them a picture of all the tickets, you could really have them figure out the probability that those routes are required by other players as well, right? If you wanted them to do that. It's a neat idea for sure. I might have to work that in more specifically than I have it now. Anybody else?
Well, the mind game seems like it's got overtones of Towers of Hanoi, which I guess is a puzzle, but I don't know if you call Towers of Hanoi a game, but Towers of Hanoi is very much math related, right?
Yep.
Solutions.
That's actually in our discrete class as an example for something. It's a wonderful, wonderful thing to use for that class. So I think we use it in an algorithms section and then have them try to write out sort of a proof structure of why solutions work sort of deal. But I think it's an algorithm part of the course for us. But yeah, it's a really neat historic game there. I've never had them just play it though. I should really bring it in one time.
You mean you've never had them figure out the minimum?
No, we have. Yeah, we have, but it's only on the chalkboard. I've never brought in a physical thing they can play with. I should do that one of these times.
What about Mastermind for Logic?
I've thought about that one actually, but I haven't gotten a chance to dive in to figure out how I would make the assignment part. So that one jumps out at me as well for that. The other one that jumps out at me for graph theory, by the way, is Pandemic. I don't know if anybody, I know it's a buzzword that probably people don't want to hear. Anyway, so
You've already
that,
played.
the worst thing about that game is usually if you cure all the diseases, the world's in shambles. So if you guys don't know, it's another game that's played on a board where the cities are vertices and there's edges showing you where you're allowed to move. And there's diseases that spread through the game, and you're kind of the CDC people trying to cure the diseases while keeping things in check. It's a cooperative game. It's actually a really good game. It has some very, very nice things for this course because the degree of vertices is super important in that game in a couple different ways. Degree of a vertex, I haven't tied into the Ticket to Ride yet, although I think it could be, as to why certain places are strategically better to build than others. So the degree of vertex comes in pretty well, but then there's also cards in that game, so probabilities can also be easily pulled from there, but there's just not enough graph theory that I can really pull out in an assignment so far. I've even had kids play it and did a trial assignment and it came up short. So that one's a work in progress. I really want that one to work.
Well, it's a little more complicated.
That's also part of it. Yeah, it's got more rules and mechanics, but it's another good graph game. I just don't know that I haven't gotten that one to work as well for what I want it to be yet. So, anything else? Okay. I know I should have had my email in case anybody really wants to email me about anything. And I didn't put it in the slide, which is a no-no. And I'm running right into the screen. I'll go behind it with the EDU. I think you guys can figure that part out. So my email is martinrw1@sunybroome.edu. If you have any thoughts about ideas that I could maybe try out, or thoughts about the stuff I did, questions about it. I did bring some copies of the assignments I have worked on for the Mind and for Guess Who. If anybody's really just interested in seeing what that might look like. They could both be broadened very easily into bigger assignments, but starting point of kind of what I have in mind with all of this and what I tend to do. Okay.
What about your math club? Do they play games?
So a student finally started that last semester, and it is very much still trying to get the ball rolling club. And because it's a student-run club, I can't just take it over. It wouldn't be the right approach. So if I can get it's something I would like to bring into part of that for sure. I just gotta get them to. Vising is new to me. So, anything else? Okay, well, I guess thank you guys for listening to me talk for an hour and for having me here. Enjoy your day. I think that was okay. All right. I shouldn't touch that. Have a good one. Yeah, thank you. Good to see you too.
Thank you.
Bye.
I was gonna